everybody, good morning. So today is November 6th and we're in the 12th weeks. How many weeks left? So this week, 2, 3, 4, 5, and then the final. So we have 5 weeks of classes, then the final. And 1 week was the Thanksgiving break. So you only have 4 weeks of classes. Okay? So, right. And this month, you're gonna be very busy. Okay, everybody. Remember, I want everybody to pass this course so I can see all of you in spring applied Calculus II. Okay, so practice exam is due tomorrow midnight. And exam 3 is on Wednesday. So Wednesday, come here early. Like before, if you need more time, feel free to stay longer after class. I teach Cal 2 in this classroom after our class. So, but I will be teaching Cal 2. So, but if you finish, just put your exam here and then leave. Okay, everybody, if you need more time. Okay, so I have already graded your quiz. So let's take a look at the quiz. Okay, so quiz solution here. All right, so this is the quiz solution. You need to discuss the function with respect to concavity, points of inflections, and local maxima, minima, and use the information to sketch the curve. So the first thing you did was like taking the derivative and set it equal to 0. You find two roots, 0 and -4, right? And you take one more derivative, that's the second derivative. You set it equal to 0, and then you find the roots are 0 and -3. And because this is a polynomial, the domain is all real numbers, right, everybody? And so domain are real numbers, you draw the real number line separated by those important points, right? So 0, -4, 0, and -3. And remember this table, you want to include f prime, and f, right? For f prime and f prime, you want to answer positive, negative, or 0, or does not exist, right? So let's look at f prime first. The roots are 0 and -4. So they are the roots. Do you see these 3 boxes? It's actually the same sign, everybody. So you can put a box here to indicate they are the same sign. And then we plug in the factor form, therefore you get plus, and then all these are negative, and this is plus, right? And then for the second derivative, 0 and -3, we get 0. Do you see this 3 region is going to be same sign? Yeah, so you just plug in maybe -4 here, then you get negative. So all 3 regions are negative. And this is positive. This is positive. Okay, everybody? And actually you can tell from the multiplicity of the roots. Multiplicity, everybody look at me. Multiplicity is the power of the corresponding factor. You know the power is even. That means x squared is always positive. So when you pass by the 0, it won't change sign. Therefore, for the 0, do you see it's positive here, it's positive here, it won't change sign. And do you remember when you draw, like, when you find inequality, and if your multiplicity is even, you bounce off. Okay? If your multiplicity is up, you cross because it changed sign. And then here, the -3, do you see the multiplicity is 1, which is odd? So it changed sign. Therefore, if positive and negative, it changed sign. So you can also tell from the multiplicity. Okay? And remember, what do you want to draw for f? Well, it's a circle. You cut it into 4 pieces, right? And you get increasing, you kind of take down. So this piece, and decreasing concave down, the speed, decreasing concave up, and increasing concave up. Right, everybody? And then you plot those important points and you draw them on the graph. Okay, these important points, put them on the graph. And then each piece, copy and paste. Make sure I can tell the concavity. So make it more obvious. Don't just do this. This I can tell the concavity, right, everybody? And polynomials are very smooth, so you should not see any corner. Okay, it should be very smooth. So like this. Okay. Let's look at the mistakes. So we learn from the mistakes. On exam 3, you have some problem to sketch the graph of the function. Let's see, where's, so start from here. Okay, so that's why I hope after you put the important points, write down the interval. Okay, please write down the interval, because otherwise you might forget there is an interval and you need to put the sign there. Okay, everybody? So after you put the important points, the real number line separated by some intervals. Write down the interval, then you won't miss it. Okay? And so that's why here, increasing, and then here decreasing and concave down. And -3 is the important point. So plot that. What is this number? And then do you see here? Make it more obvious. See, it's concave down. Here, make it more obvious, so it's concave up. So everybody understand my requirements? Make it more obvious. Okay, so yeah. That's why I do 1 point. So you need to tell me the important point. What is f of -3? Okay. And then here, make it more obvious. Do you see this one is just like I cannot really tell it's concave up or concave down. Do you agree? So make it more obvious. All right. I didn't take up any point because I know all of these are correct. But on the exam, be more obvious. Okay. Continue. Oh, here, when we factor out x squared. So we only have x plus 3. So we only have 1 root instead of 2. Okay, that's why we don't have this. And remember, polynomials are very smooth. So if you see your answer has the corner, what does that mean? If you see you have a corner, and there's some mistake, right? Go back and check your work. Okay? So yeah, and then f of -4 is 256. Okay. All right. Oh, here. Yes. So this is plus. This is plus. So is increasing and concave down. Okay. Okay. If we follow this, is increasing and concave down, right? Increasing and concave down. Oh yeah. That's increasing and concave down. Oh, then it's like this, increasing and concave down. So yeah, please draw the circle, separate into 4 pieces, and then you will pick which one, okay? And here, make it more obvious, because it looks like concave up instead of concave down. Okay, everybody, look at me. So I hope on the exam, this problem, make sure I can see the concavity. And here, make sure I can see the concavity. Okay, everybody? All right. And, okay, the problem asks you to label concavity, inflection point, and local max and local mean. So write this down. Okay, everybody? So, yes. So know the requirements. And I hope you don't miss points on the exam. Okay, so just write down all the requirements. Okay. Any questions about the quiz? No? Okay. So How about let's take a look at the practice exam. Have you started the practice exam? No. Okay, let's take a look at it, okay, together. But the practice exam is due tomorrow, okay? So you do your homework and do the practice exam. So the first problem, this problem, I give you the graph of the derivative. Be careful. This is the graph of the derivative. This is not the graph of the function f. Okay, everybody? So be careful, be careful, be careful. Do you see this point, -3 and then 1 and then 2? Above that, the derivative is positive. And below that, the derivative is negative. Okay, everybody? So say the open interval over which the function is increasing or decreasing. F is increasing when the derivative is positive. Right, everybody? So you don't say, oh, you don't say from here to here. No. This is f prime. This is not f. Okay? It's increasing when f prime is positive. So f prime is positive on, where? This piece, minus infinity to -3. And this piece, right? 1 to, what is that number? 7. Yes. And then f is decreasing when the derivative is negative, right? Negative. Where is negative? Here, -3 to 1, and then greater than 7. Okay, everybody? So if you consider this is f instead of f prime, you get the whole problem wrong. Okay, everybody? So only except, be careful. This is f prime. This is not f. Okay? So this problem, you gotta be very, very careful. Because, yes.
How would you know it's increasing though, by looking at the graph, increasing or decreasing?
This is f prime. Remember, f is increasing if the slope is positive. Slope is the derivative. So f is increasing when f prime is positive. F prime is the slope of the f prime. Right? Increasing, your slope is positive.
Yeah.
Decreasing, your slope is negative. And critical point, your slope is 0, or in the corner, then slope is not 0.
Okay. Yeah. But it says negative infinity to -3 is increasing, but it's going like this.
No, that's what I'm saying. You don't, this is f prime. Don't look at f prime as increasing or decreasing.
Okay.
If the f is increasing when the f prime is positive. I don't care the shape like this or this or this, as long as it's positive. Okay. So we don't care about whether the function f prime is increasing or decreasing. We just care about whether it's positive or negative. Okay, everybody? Maybe it looks like this. That's okay. As long as it's positive, then f is increasing.
But how would you know it's positive?
It's above the x-axis.
Oh, okay.
Yeah. Remember, the x-axis is when the y is 0?
Yeah.
Above it, then the y is positive. Okay. Below it, the y is negative.
Gotcha.
Yeah, that's why this problem, okay. Be careful, everybody, because if you look at this as SF, and the whole problem you get 0. It's 0. You lose 12 points, which is a lot. So everybody, yeah. That's why I want to look through the practice exam and make sure you understand this. Okay. All right. And then say the exercise for the relative max and mean. Critical point is when the derivative is 0. So those 3 points. And then you can see here. So you can look at the graph and you can construct the table, right? So you have those 3 points. Your f prime here, positive, and then here, negative, and then here, positive, and this negative. And then you look at your f. Ooh, increasing, decreasing. This is the local max. Right? Decreasing, increasing, this is local min. Increasing, decreasing, this is a local max. Okay, everybody? So you look at the graph of f prime, you can construct the table. And state that if the interval where the f is concave up or concave down. Okay, concave up and concave down, remember, that is the second derivative, right? Second derivative is the derivative of the first derivative. So which means is where the slope of this f prime is 0. So we have this point like negative 1.3 and this point is 4.5. Okay, everybody? The second derivative is the derivative of the first derivative. Remember, the derivative is the slope of the tangent line. So the second derivative is 0. It's the same as when the f prime has maximum min. Okay, which is those points. And then you can look at this graph. Your function f prime is decreasing. Your f prime is decreasing. It means your f prime is positive or negative? Decreasing. F prime is decreasing. So your f prime is negative.
Wait, your f double prime?
Yeah. F prime is decreasing. Then your f prime is
then that's negative.
negative. Yes, and then here f prime is increasing. The f prime is
Increasing. Positive.
positive. And then here it's f prime is decreasing. The f prime is negative. That's why you draw this picture, right? So your f is decreasing, concave down, concave up, concave down, and those are the inflection points. Yes, everybody? So yeah, and then you can answer all the questions. Okay. So yes, try this problem again. And okay, this one. So what is this problem about? You find the interval where it's increasing and decreasing, right? So you take the derivative and then find the critical point. And remember all the derivative formula. Okay, make sure you remember all the derivative formula. What's the derivative of x to the n?
N times x to the power of x minus 1. Or n minus 1.
Yeah, n minus 1. And then how about the derivative of e to the kx? K times e to the kx. How about the derivative of natural log of x? 1 of x. And what is Parada's rule?
U prime b plus u prime.
Motion rule?
U prime b minus ub prime over u squared.
Just b squared, yes. So review all the derivative formula, okay? And chain rule is whatever formula you multiply by u prime at the end. Okay, everybody? So you take the derivative, and remember, our goal is to factor. Combine into a single fraction. Numerator equal to 0 corresponds to the derivative is 0, right? Denominator equal to 0, it corresponds to the derivative does not exist, right? Then you can find the domain. See, this problem, if the domain you miss that point, you put an open circle to indicate that point is missing. Okay, everybody? So therefore, you can draw the table. Because here it does not require you to sketch the graph. You don't need to include the second derivative. Okay, remember this problem? You find the AB such that the function is continuous, right? So continuous, you look at the right side limit and the left side limit, set them equal to each other, and make sure which one has the equal sign. That also equals to f of 1. Remember, if you forget f of 1, you lose 1 point. If you forget the limit, you lose 1 point. Okay, to carry the limits every time when you still see x there. And then part B, you find the values of a and b such that the function is differentiable, right? Differentiable, the right side derivative and the left side derivative, you set them equal. Is that okay, everybody? And this problem, you get an equation here, you get another equation here, you get a system of two equations. You know, system of two equations, you can use elimination method or substitution method to solve it. Okay? Yes, so do this problem at home, and then it's due tomorrow. And then this is like your quiz, right, everybody? This is like your quiz, you draw it. Okay, and then here you take the third derivative. So you take the first derivative, second derivative, and third derivative. But make sure you change them to the what? The standard form, right? Okay. And also this one, change it to the standard form, and you can take the derivative. And this one, oh, okay. Find the time when the concentration is maximum. So this is a function, find the maximum. You also take the derivative, and then find the critical point, find the domain, and draw the table to find the maximum, right? Okay. And then this one, if you have a closed interval, you find the critical point, and then you look at which critical point lies in this interval. If both of them are in the interval, then both of them are the critical points, right, everybody? And then you plug in the endpoints and the critical points. The largest number is going to be the absolute maximum value. The smallest number is the absolute minimum value. Okay, everybody? Yes. So those are all the problems on exam 3. Any questions? Okay, so please do the practice exam, and it's due tomorrow midnight. Okay. Let's continue. So 6.3. 6.3, we talk about elasticity of demand. The formula E equals negative P over Q times dQ dP. Yes. Oh, different alarm, right? Yes. And I just.
You're so focused on explaining it.
It's so natural. When you're sleeping, the alarm rings and turn it on. You just sleep. Okay. All right. Oh, by the way, because the time changed 1 hour, but do you really feel you sleep 1 more hour? I don't feel that. You feel that? Okay. I still feel sleepy. Okay. Okay, do you still remember this elasticity, right? Okay. And if E is less than 1, then the demand is inelastic, right? It's like milk or gas or water, you still need to buy them anyway, dairy products. Demand is elastic when the E is greater than 1. Okay? Like some computers or like necklaces, jewelry, you watch for a Thanksgiving sale to buy it, right? You don't need it right now, you can wait a little bit longer. Okay, so last time we have example 1 and we compute the E and we plug in this price, we get the E is less than 1, so demand is inelastic. Right, everybody? Okay, so let's continue. Okay. So, relation between revenue and elasticity. So, revenue is price times demand. Does that make sense? Revenue is the money you earn, right? It's the price times demand. That's the sales, right? Okay, so R equals P times Q. And then profit is revenue minus cost. Yes. Okay. So you see, Q, the demand depends on the price P, right, everybody? So R and Q are functions of P. So when you take the derivative, you're doing product rule, right? Product rule, it will be P prime Q plus PQ prime, right? So P prime derivative of P with respect to P is 1, right, everybody? P prime is 1, and then that's why you have Q. So P prime is 1, you have Q. And then plus PQ prime. And the orders switch a little bit, okay? But it's okay, it's addition, you can change the terms, change the order of the terms. Okay, and then here, what do I do is I multiply by Q and divide by Q. This term I multiply by Q and divide by Q. And then I also put a minus sign. So positive is like negative times negative. Okay? And let's pull out the Q. Okay? If we pull out the Q, do you see this is negative P over Q times dQ dP? This is the E, right? Elasticity. So, and then this is it. Do I just copy again? Yeah, I think I just copied this again. So yeah, this is the E, right? This is the E. Oh, these are the same. Why do I copy so many times? Okay, interesting. So that is the E. Okay. All right. Yes, that is the E. So we get dRdt is negative Q times E plus Q, right? And can we factor out the Q? Then we get minus E plus 1. That is 1 minus E, right? Okay, now let's see. This is the derivative of the value. We want to find, okay, when can you maximize the revenue, right, everybody? Maximize the revenue. So we take the derivative, we set this equal to 0. Do you see if we set this equal to 0 to find the critical point, we get E equals to 1? Yes, everybody? So when E equals to 1, our dRdP equals to 0. And then you can draw the real number line, right? So we have E is 1 here, and this is less than 1, and this is bigger than 1. Okay, let's do this. And now, let's see. We have R prime and R. So we know when we plug in E equals to 1, we get R prime is 0. Right, everybody? And then if E is, so this is E. So if E is less than 1, or you can peg E to be, for example, 0. Right, everybody? If you plug in 0, do you see Q is demand. Demand is greater or equal to 0, right? And then 1 minus D is 0. Do you see we just get Q? Q is positive, right, everybody? So you get positive. And then when you plug in E is, let's say, 2. Oh, do you see Q is positive, but 1 minus 2 is negative? So the whole thing is negative. Oh, that's why your R is increasing and decreasing. You get a maximum here. Right, everybody? And this is the picture of R. And this is P, and then this is, oh, I think this is E of P. Okay. Okay. So this is E. And this is at 1, when E equals to 1. So you have increasing and decreasing. This is the maximum. Therefore, if the demand is inelastic, so that means the E is less than 1, right? Then less than 1 is here. Our revenue increases as price increases. Okay. Let's see. E is this. And on the other hand, if the demand is inelastic, so E is greater than 1, the total revenue decreases as price increases. Right, everybody? Okay, and then the total revenue is maximized at the price when the demand has the units. Okay, let's see. All right, so I think this is P, this is not E. Okay, I think this is P. But let's figure out like P. So we want to know whether E and P increase at the same time. If you look at E, E is negative P over Q and then dQ dP, right? And if P increases, well, your P increase, then your Q decrease because Q is the demand. If your price is higher, do you want to buy more? No, you want to buy less, right, everybody? So if P increases and then our Q decreases, right? And then that's why here dQ/dP. Okay, because the Q decreases, then the dQ/dP is negative, right, everybody? Because your function is decreasing, it means the slope is negative, right? And then therefore, oh, we have a negative here and we have a negative here. Therefore, the E is positive. Okay, your P is positive, Q is positive, but dQ dP is negative, and oops, sorry. So E is positive. Okay, E is positive, but your P is increasing, your Q is decreasing, so your E is actually bigger. Because you have bigger numerator, the smaller denominator. So your E is actually increasing. That's why when the P increases, your E also increases. Is that okay, everybody? So yeah, that's why you can say this is P or E. Okay. All right. So let's do example 2. So assume that the demand for a product is Q equals 216 minus 2P squared, where P is the price in dollars. Find the price interval where demand is elastic and when the demand is inelastic. Okay, and what price results in maximum value? What is the maximum value? Okay, so let's find the E. All right, so E is negative. So this is how I remember. Your Q is a function of P, right? So you always take the derivative of Q with respect to P, right? And then here, this fraction is gonna, you flip the P and Q. So this is the Q over P, then here will be, so then you get P over Q. Is that okay, everybody? So this is how I remember this formula. Okay, so what is dQ over dP? Well, the derivative of 216 minus 2p squared. What's the derivative? Negative 4p. Yes, the derivative of 216 is 0, and then that one is the power rule. Okay, good. Now our E is plug in negative p. Q is what? 216 minus 2p squared. Yes, everybody? And times the derivative, which is negative 4p. Right? Everybody? Okay, that's why the negative cancel. Numerator, we have 4p squared. Denominator, we have 216 minus 2p squared. Is that okay, everybody? This is the Y. So we want to find the price interval when the demand is elastic. Elastic means our Y is what? You compare with what number? 1. Okay. So when is the Y elastic? I mean, the demand is elastic when Y is greater than 1. Okay. So if Y is 1, what does that mean? Well, that means if your price increased 10%, your demand increased 10%. It's the same ratio. Okay, everybody? If your E is less than 1, it means the price increased 10%, the demand will decrease less than 10%. Right, everybody? So that's why your demand is not so sensitive to the price increase, right? But if your Y is, oh, sorry, sorry, I mean that one. If your Y is greater than 1, so if your price increases 10%, your demand will decrease more than 10%. So it's very sensitive to the price change. That will be elastic. Okay, so if your Y is less than 1, then your demand decrease with less than 10%, right? Okay. So therefore, when is the Y greater than 1 and when is the Y less than 1? First of all, you want to find the domain first. Okay. What's the domain for P? Well, you need the demand Q to be greater equal to 0. Do you agree, everybody? Or you if you don't want it to be 0, you can exclude the 0. You want the demand to be positive. You want somebody to buy your products. Do you agree? You don't want your demand to be negative, so nobody buy your product and you have to give them the product. Okay, so interesting. So Q is the demand. We need the Q to be positive. So that means 216 minus 2p squared greater than 0. Is that okay, everybody? This is the demand. And let's solve for P. How do we solve for P, the inequality? Oh, we add 2p squared, right? Then we have 216 greater than 2p squared. What do? Divide both sides by 2. By the way, when you work with inequality, you can add or subtract any number, right? It won't change the inequality sign. If you multiply or divide it by a positive number, it won't change the inequality sign. But if you multiply or divide it by a negative number, the inequality sign will flip, right? Yes. So that's why here 108 greater than p squared. Well then, when you take square roots, because the square root is increasing function, so when you take the square roots on both sides, your inequality still preserved. Is that okay, everybody? So this is true for all the increasing functions. Okay? So if you take square root, the inequality is still preserved. How about this is e to the x, right? So if you have 2 less than 3, when you raise to the e squared and e cubed, it also preserves the inequality. Okay, everybody? But what is a decreasing function? Well, for example, this is outside of this problem. You know, 1 over x is a decreasing function, right, everybody? So therefore, if you have 2 less than 3, and when you flip them, you apply the a 1 over x to it, your inequality will be flipped for a decreasing function. Is that okay, everybody? Okay, therefore here you get, p less than square root of 108. Oh, and be careful. When we take square roots, we actually get like the absolute value, okay? But here you can, because your price, we know that the price must be greater or equal to 0. Do you agree? Can your price be negative? No. So therefore, if we know the price is greater or equal to 0, then when we take the square root, you don't need to consider plus or minus. So therefore, what is square root of 108? That is approximately equals to 10.39. Therefore, your domain for P is 0 to 10.39. So this symbol, it means belongs to. So it means P belongs to this interval. Have you seen this symbol before? Yes, it's like a C and a line segment in the middle. Okay, so this is the demand. So we haven't like solved our problem yet, because the problem said we want to find the P such that the Y is greater than 1. And Y is what? This is Y. So 4P squared over 216 minus 2P squared. This is greater than 1. Okay, everybody? We want to solve a P. But do you see this is the denominator? You don't want to see denominator, right, everybody? So you want to like both sides multiply by this. But when you multiply by this, you gotta be careful. You want to ask, is this guy positive or negative? Because if this is positive, when you multiply it, it won't change the inequality. But if this guy is negative, when you multiply it, it will flip the inequality. But when we find that domain, do you see this guy is always positive? So when you multiply this thing on both sides, because it's positive, it won't change the inequality. Okay, everybody? Yes. So we multiply this on both sides. We get 4p squared greater than 1 times 216 minus 2p squared. Yes? And because we can do this because both sides we multiply by the 216 minus 2p squared, and then this thing is positive, so we can do that. All right, now we have 4p squared greater than 216 minus 2p squared. What do you do? Yeah, plus the 2p squared. And then what do you get? 6p squared greater than 216. Yes, everybody? So we get p squared greater than 216 over 6. What is that? Is it divisible by 6? 3 times 6 is 18, and then we have 3, 6. Oh, is it 36? Yes. Is it 36? Yes. Okay. Oh, when you take square root, what happened? What's square root of 36? Yes. Oh, see? If p is greater than 6, then we get the demand. So we can say demand is, because E is greater than 1, it means demand is elastic. Okay? When P is in, right, you have greater than 6, but in the domain, you cannot exceed 10.39. Okay, everybody? And similarly, so you get the demand is inelastic when the P is less than 6, which is like 0 to 6. Right, everybody? Okay, because if you change this sign to be less than 1, this will be less than that, less than that, and less than that, and less than that. You just change all the greater than to less than, right? And we get units. So you get E equals 1 when the P is 6, right, everybody? And furthermore, we just showed that when E equals to 1, the revenue is maximized. Okay, so part B, what price results maximize revenue? Okay, maximize revenue, you get like part B, maximize revenue when the P equals to 6. And what is the maximized revenue? Okay, revenue. Okay, sorry, let's continue here. Revenue equals demand times price. Do you agree? Demand is 216 minus 2p squared. And then your price is p, right? So you plug in 216 minus 2 times p is 6, right? You plug in p equals to 6. So R of 6 is, what's p squared? 36 and then times 6. Oh, 216, what's 2 times 36? 72, right? What's 216 minus 72? 144. Yeah, 144 times 6 is, any calculator? What's 144 times 6? Thank you. A64. Oops, what happened? Okay. A64. So that finished the problem. Okay, so we're given the demand. Demand is a function of price. Okay, and we can compute the E. Demand is elastic when the E is big. What do you mean by big? Bigger than 1. So for E, we compare with 1. We don't compare with 0 because we know it's always bigger than 1. Okay, so we compare with 1. Is it bigger than 1 or less than 1 or equal to 1? Right? So, okay, so this is 6.3. And you have homework problems about the elasticity function E. And so Wednesday, you have exam, okay? This afternoon, I have office hours from 3:15 to 4:30. If you have questions, feel free to come to me. And tomorrow, I also have office hours from 11 to 12. And so if you're not available during my office hours, feel free to email me. We can go to the TED Live, so we can meet in the evening. We can go to the TED Live. You can share your screen and ask me questions. Okay? So Wednesday, come here early to start the exam early. And then Friday, clean our worksheets 6.4. Okay. Bye. Have a good day. Thank you.